Hey everybody, it's MoNaCo
And Milks.
coming to you with the last lecture in the
Oh,
unit.
woohoo! See you later.
Nice. So page 34, I think it is.
Yep.
Calculating limiting reactant. What do we mean by limiting reactant, Mr. Milksies?
What we means is we're going to run out of something.
Oh, so you mean like if I'm trying to make pancakes but I don't have enough mix?
Yeah, yeah. Well, what we do is we usually use like peanut butter and jelly sandwich where I have multiple ingredients.
Oh, okay. So I got a tub of peanut butter,
Yep.
I got a tub of jelly, but I only have one loaf of bread. I got 10 slices.
I'm probably going to run out of bread first.
So that's what you mean by limiting reactant.
Then the reaction stops. I'm no longer making peanut butter and jelly sandwiches when I'm out of bread.
Cool.
So that's really what it is.
Right. And yeah.
So we just got to figure out which chemical that is.
And that is what we're doing here.
And this is really the name of the game with moles of stoichiometry.
Right, and we actually used this idea to make sure that when we started this unit, when we did the silver chloride reaction,
Yes,
we wanted to stop the reaction at exactly 1 gram of
So we
product.
calculated how much to put in to limit the reaction.
So we
created the limiting reagent.
we created it on purpose.
So by definition, the limiting reactant is when a reactant runs out, the reaction's going to stop. And that stopping of the reaction limits, right, how much we can make.
Right, if I run out of something, I can't use it
So I'm
to
going to call that the limiting
make a product.
reactant or the limiting reagent. I got them both up there because I want you to know they are synonymous.
Reactant, reagent, synonymous.
You could see that. You're probably going to see limiting reagent all the time, and
Yeah.
I need you to know that that really means reactant.
Yeah.
So maybe we got to throw that in with the vocab
Sure, next time around.
next time around. You know what I mean?
Sure.
So,
Limiting reactant problem-solving process. So this is true moles of stoichiometry. It's what Mr. Milks and I reasoned through and calculated through at the beginning of this
this
unit
is
in our
the
video.
creme de la creme, if you will, of the unit.
And you can go ahead and watch that video again.
Yeah, if you
Part
can
one
do
and
this, and at the end of this, you might want to watch that again.
Mm-hmm.
Because I'm going to do one problem in this that's going to mimic that other problem that we did very simply. So always 2 steps, because I have to run the stoich through twice.
And if there were 3 reactants, you'd have to do it 3 times. But we're not going to get there.
You're thinking, you will not, right?
Right.
So I'm going to run the reactants through both times
Right.
to a common product in grams. The product's got to be the same, because I
Right.
want to compare apples to apples, not apples to oranges.
Basically, what you're telling me is that you're going to figure out which one of the reactants produces less product because that's the one that's going to run out first.
That's it. So that's the limiting reagent or
Right.
limiting reactant.
And then you can effectively say, listen, if I have this much ingredients, I'm only going to make this much product.
Right, and it doesn't matter how much you have of the other ingredient because it's going to stop.
I got a whole tub of peanut butter left over. I don't care. You don't have any bread. You only made 10 sandwiches. Done.
Done.
Got
So
it.
there you go. So let's do them. Okay, so I have a balanced chemical equation up here.
So, ooh, you got those notations in there. So
I
let me
do.
read this. 4 moles of NH3 gas
Yep.
combines with 5 moles of O2 gas
Yep.
to create a reaction and make 4 moles of NO gas and 6 moles of H2O gas.
There you go.
Cool.
And it says I'm going to start with 2 grams of NH3,
And 4 grams of O2.
and which will be my limiting reactant.
Where are we writing this down?
Well,
You
because
have
you
blank
guys
pages.
you guys have a bunch of blank pages because we unfortunately did our
Single sides.
single-sided. So you got some room on the back of this notes to do this.
So insert this example on the back side of this page.
Yes, just so you know how to do it. Now, Mr. MoNaCo, I'll run these through. If you pick me, which one do you want to be the common product? Do you want it to be NO or do you want it to be H2O? You pick.
Well, I know the gram formula mass of H2O is 18, and I got that memorized, so I'm going to say H2O.
Perfect. I'll make my life easy. So I'm going to mark that just so I know.
And I'm familiar with H2O.
And so I'm going to mark that because that's where I'm going to end up.
That's what we
So
made.
now what I need to do is I need to start with this and start with this. Take both of them to the end.
So let me just verbalize this. You're going to take the grams, turn it into moles.
Yep.
Then you're going to use the
Mole
moles
ratios we just learned.
and the mole ratio from this equation to get into moles of H2O,
Yep.
which you're going to then go back into grams.
Yep.
And you can do that twice to see which one of these makes less.
Okay.
Cool.
You're not timing me, are you?
I am.
Oh boy.
No.
All right, I got 2 grams of NH3. Times.
Moles, 1 mole.
Right. Now what I want to always do is I want to have the grams of NH3 in the denominator,
Right.
so it cancels.
So,
1
1 mole,
of NH3,
right, divided by 17 grams.
17 grams in that 1 mole.
Grams NH3. Yep, that's the gram formula mass that we used and calculated so many times.
Yep. So I'm going to go ahead now and just cancel off my grams.
Yep, and now you're into moles of NH3.
I am in moles of NH3, so now I need to come up with a mole conversion from 4 moles of NH3 to 6 moles of water.
So we need to cancel moles NH3.
So
that's going to
go on the bottom. The balanced chemical reaction tells me it's 4.
Yeah.
So it's 4 moles of NH3 for the 6 moles of water.
H2O.
And so now I'm gone with this moles of NH3 is gone.
Yep.
And now I'm into water.
And now you got to get from moles of water to grams of water.
So let me do that. So 18 grams of water, which is what I want, over 1 mole of water. And now notice, like we did in our practice pages, we did one way and one the other way, right?
Right.
Because so this conversion factor, grams is in the denominator, and in this conversion factor, grams is in the numerator, but I'm allowed to do that because I'm letting the units be my guide. Let me cancel out these. And what we're doing in the calculator now is when we multiply fractions, what we do is
We go all the way across
all
the
the way
top.
the numerators and multiply them. So that's 2 times 6 times 18
Times 1, but yeah.
times 1. I skipped that because I know what times 1 means.
2 times 6 times 18.
12 times 18 is
216.
216
Over
over 17 times 4.
17 times 4. 68.
68. Now plug that into my calculator.
3.17
3.17
grams of
water.
H2O.
Okay,
Put a
good.
box around that
All right.
and put it answer 1.
Well,
That's
I'm going to put a box around it, and we're going to compare which one's higher.
because now you're going to do the same exact thing, but with 4 grams of
of the
O2
to see what happens.
to see if we can get to grams of
So I'm
H2O.
going to switch colors.
Okay.
Let me start with my 4 grams of O2.
Times 1 mole
Yep.
O2 over, well, 32.
32 grams.
32
Remember, it's
grams.
diatomic.
Grams O2. Yep.
So that's going to, now I'm going to lose my grams of O2.
Yep.
And now I'm in moles of O2. Now I got to get from moles of O2 now to moles of H2O.
So we got to use a different mole ratio
That's
here.
5 to 6 in this case.
Right.
And I want moles of O2 on the bottom. I'm going to do that right away.
5
from my balanced chemical equation.
5 moles O2.
Yep.
Good.
And then 6
6
H2O.
H2O on the
Leave
top.
that word mole off for
Sure.
We're starting to get the hang of what I'm doing. So
And
now
then-
I'm in moles of water.
And we got to get into grams of water.
And now look at that same conversion factor too.
Because we picked a common product to work
Right.
with.
So it's 18 grams of water for 1 mole of water. My moles of water is going to cancel, and I'm on to calculator time.
Calculator
4
time.
times 6 times 18.
And that is 432. Whoa, maybe we're going to get a lot of divided by.
That's all right. I got 32 times 5, which is 160.
Yep. So 432 divided by 160, 2.7.
2.7 grams of water
Is a product.
is my product. Now I'm going to evaluate. Which one made less water? 2.7, 3.17, which one's smaller?
2.7.
So this is the big winner.
That's the limiting reactant.
This one is the limiting reactant, which means oxygen to start with was the
Limiting reactant.
That's it.
Your reaction was limited by the amount of oxygen that you had put in, and you wouldn't know it by looking at the masses because you said there's more oxygen than ammonia. It
Right.
must not be that.
So there are two, just here, I'll do it in black. There are two things here that are going to, well, really, 3 really. There's this that's going to be different, there's this that's going to be different, and
the
this thing is going to
So
be
the first 3 steps,
really
getting from
determined.
grams of reactant into moles of reactant into the mole ratio, are the first 3 steps that are going to be different.
Right, and they're going to change from reactant to reactant. We got to really follow the process. There's no shortcutting this.
Yeah, no, there isn't.
We got one practice we're going to do in class, and then we're going to,
Move on with ourselves because
this is the creme de la creme of the unit. We want to make sure we have some of the skills.
thank you all for watching.
What a great unit it was.
It was fun. I look forward to writing your next one.
Yeah.